Hello all, welcome to Coder. Today let us solve the lead codes daily challenge and the problem is set mismatch. You have set of integers which originally contains all the numbers from 1 to n. Unfortunately, due to some error, one of the numbers is yes got duplicated to another number in the set, which results in the repetition of one number and loss of another number. That is, you have set of integers in yes which originally all the numbers from 1 to n. We have 1 to n numbers in the set yes. Unfortunately, due to some error, one of the numbers in yes got duplicated to another number in the set. One number got duplicated. If n is equal to 3, then the set contains 1, 2, 3, and there is one number that got duplicated. Let us consider that this 3 got duplicated twice, the 3 duplicated once, so it will be 133, which results in the repetition of one number and loss of the another number. That is, the repetition is 3 and the lost number is nothing but 2. So this is what I have done in this case. You are given an integer array in nums and you are given an integer array in nums representing the data status of this set after the error. They have given this this is represented as the nums. This is the nums array that is they are giving. So find the number that occurs twice and the number that is missing and return them in the form of an array. That is, we have to return an array which is the missing number, the number which is repeating and then the missing number, repetition and the missing number. So this is what the problem states. So for this example 1, the array is 1 2 2 4. Obviously the repeated number is 2 and the missing number is nothing but 3. So you can see that the answer is 2 comma 3. And for example 2 1 comma 1, the repetitive number is 1 and the missing number is nothing but 2. So this is very quite simple problem. Let us see different approaches to encounter this problem. So obviously, to find a repetitive number, we can have a map. We can have an unordered map in comma int, and we can have an unordered map in comma int, and we can first store the number in our map, store the frequency mp of x plus plus, and the repetitive number is nothing but its frequency will be 2. The repetition number frequency is 2 and the missing number frequency will be 0. Frequency is 0. So this is what we can observe from this map. So what we can do is we can run a for loop from I equal to 1 till n. I less than or equal to n, I plus plus. If my mp of I is 0, then this is my missing number. Missing is nothing but my I. And if my mp of I is nothing but, so if the frequency mp of I is equal to 2, then the repetition or we can say it as duplicate number is nothing but this I, and finally I can return the duplicate comma missing. So this is what they are expecting, and we can just return them as duplicate comma missing. And let us try to submit the code as well first. So n is not given. We want to take the n, so nums dot size. Now let us try to run our code. And for this approach, what is the time complexity given? Not declared into missing and repetition or duplicate. For this approach 1 using space, using map. So the time complexity will be order of n, and the space complexity is also order of n. So this will be an approach 1. Let us see the optimized also. Let us try to submit the score. Okay, it gets accepted. Let us see an optimal approach as well. Okay, this is the approach 1. So let us look into some other approach. How we can do without using an extra space. Uh, for duplicate number, what is happening is the number is repeating twice, and you can see that the nums array size is n, and instead of using an extra space, you can use the elements in the array as indices. So use the elements as indices. So what do I mean from this? If it is 1, 1, 2, 2, 4, what will be the index for this array? 0, 1, 2, 3, and this is the index for that particular array. We are handling in zero based indexing. So let us for each and every element we can do a -1, and then you can access their index. But what do I mean from that is, you can see there are two elements or 2, so those particular index is 2 minus 1, which is 1. So index is nothing but 2 minus 1, which is 1. So 1 is the index that is accessed 2 times. So the particular element which is accessed 2 times is nothing but 2, which is the index 1. And how we can find the missing number is nothing but, we can find the missing number if that particular index is not accessed at all, because if the particular number is missing, we won't be accessing that particular index at all. The missing number is 3, and the missing index is nothing but 3 minus 1, which is 2. You can see that the 2 will not be accessed at all. How do I say that? While traversing the array, we are seeing that the element is 1, so that particular index is 0. 1 minus 1, 0. So we will try to make that particular number as negative. Next, we are accessing the element 2, and the 2 index is 2 minus 1, which is the element is 2, and the index is 2 minus 1, which is 1. So we will make that one as negative. The element at that particular index as negative, and then the next element is 2 again, and that particular index is 2 minus 1, which is 1. And the one and you can see that the element at that particular index is already a negative, so I am accessing it again. If the element in that particular index, particular index is already negative, then that is the duplicate number. So if the element in that particular index is already negative, then that is duplicate. That is the number which is duplicate number. And I will be making that particular element is negative. It is already negative, no issues. And then we are coming to this element 4, and the index is 3. 4 minus 1, 3, and I will make that element in that particular index 3 as negative. So we have done it. So after that, you can observe that all the elements are negative except that one element which is present at index 2. So the element which is at not the index, which is having positive number, is the element which is missing the index plus 1. So because that index we are not accessing at all, so that on the run we are not accessing that particular index, and that yeah, index plus 1 is the missing element. So this is, by this way we are doing the, we are reducing the space complexity. It is order of 1 and the time complexity which is order of n. So how we can do that? We are having the missing and duplicate declared, and we, what we want to do is we are going to access the index. So we can take the size n int n equal to nums dot size, and what we are doing, we are running, we are traversing the traversing each index. We are int I equal to 0, I less than n, I plus plus. Now first I should, if the element is already a negative, I cannot access a negative index. So first I will take the int element is nothing but the absolute of that particular index, nums of I. So once I have taken, I want to access the air index. So index is nothing but element minus 1 is the index. And if the nums of index is already negative, is less than 0, then it is a duplicate. Now it is, the duplicate is nothing but nums of index is less than 0, then that element is already have become this, that element have already become negative. So the duplicate is nothing but the element is the duplicate element. Else what I have to do is I have to make the element to be negative. Nums of index is nothing but minus nums of index. This will be an else case. So if that particular index, that element which is at that particular index is less than 0, then that element is my duplicate element, and else I will make that element in that particular index to be negative. So hope this is clear. And then what I will be doing is, again I will run a for loop for int I equal to 0, I less than n, I plus plus. If the element is positive at that particular index greater than 0, then my missing is nothing but index plus 1, index I plus 1. Break, we can also break it and come out of this loop. And finally I will return my duplicate and missing. So what will be the time complexity for this solution? Order of n, approach to using nums, using indices. This time complexity will be order of n, and the space complexity is order of 1. So let us submit the code. Superb, it gets accepted. And this is how we can optimize this approach. Sorry, this is our approach 2. So hope you like the solution, and let me know in the comments if there are any suggestions. I will improve it on. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.